Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. I've shared my screen. Is it visible? I've shared my screen, children. Is it visible to all of you? Aniruddhan, Niveda, Kamalika, Anugraha, Prenu, Mohammad, Pratish, Krishna Priyan, Srivatsan, Akshada, Tanishka. Is my
Yes, ma'am,
screen
it is
visible?
visible. Yes, ma'am, it is visible.
Okay, thank you. All right. Okay, so this is the question which I shared on WhatsApp with you all. So it is, if ABCD is a square with A 3, 4 and C 1, -1, find the coordinates of B and D. So we are given the coordinates of two opposite vertices of a square. We are given the coordinates of two opposite vertices A and C of a square ABCD. We need to find the coordinates of the remaining two vertices B and D. So see, the square can be named A, B, C, D like this, or A, B, C, and D like this. So we know the address of A and C. We need to find the address of B and D. Now, it's enough if you find the address of B, because when you try to find the address of B, you will get two set of coordinates. So one will be for B, the other is for D. It's enough if you find for one of them. So either D or B, you find for B or D. So if you try to find the coordinates of D, you will get two sets of coordinates for D. So the answer is, if this is D, then this is B. Or if this is D, this is B. Okay. So let the coordinates of B be X, Y. See, we have not assumed for D, because for the reason I just told you. Okay, so you can either say let D be X, Y, or B be X, Y. Okay, now see, I have mentioned here what you have to work. Or we have to work with these two conditions. AB is equal to AC. Sorry, AB is equal to BC. Because we know that in a square, all the sides are equal. Okay, so we need to work with the condition AB is equal to BC. See, we know nothing about D, no? So just it's like you only know, A and C, and now, sorry, you know the coordinates of A and C, and now you've assumed for B. So you're working with only these three coordinates. Okay, this D is not at all in picture. You're working only with these three coordinates. A and C, you know the coordinates, and B, you've assumed it to be X, Y. So condition one is AB is equal to BC. AB is equal to BC. You're going to work with that condition. And the next condition is, by Pythagoras theorem, AC square is equal to AB square plus BC square. So we need to work with these two conditions to find the coordinates of B and D. Okay. Now this one we'll understand later. This one. So AB is equal to BC. Okay, so AB square is equal to BC square. So you know how to use the distance formula. All right. And when you expand this one and simplify this, you get 4x plus 10y minus 23 is equal to 0. Please expand all this. And after simplifying, this is what you get, 4x plus. See, you have to work this. You cannot, after this step, you cannot write this step. Please work, and you must get this equation 4x plus 10y minus 23 is equal to 0. Now you stop here. See, now at this point, you will not know that you have to write y in terms of x or x in terms of y. So you can just stop here. Just stop here. Stop where? Stop here. Okay. So as of now, we stop here. We don't write this step. This step we don't write now. Now, the second condition, AC square is equal to AB square plus BC square by Pythagoras theorem, because we know, no, this corner is a right angle. So this is the hypotenuse and Pythagoras theorem. So AC square. So using the coordinates of A and C, x2 minus x1 the whole square plus y2 minus y1 the whole square. AB square. Again, x2, AB, no, so using the coordinates of A and B. Again, x2 minus x1 the whole square plus y2 minus y1 the whole square. Then BC square, using the coordinates of B and C, BC square is again x2 minus x1 the whole square plus y2 minus y1 the whole square. Again, on expanding and simplifying, we get this equation. You have to show the steps. So we get this equation. Now look at the two equations you've got. This is x squared plus y squared minus 4x minus 3y minus 1 is equal to 0. This is quadratic. But this one is a linear equation in x and y. So we have to use a substitution method. If both the equations are linear equations in x and y, yes, you know the different methods to solve and find the values of x and y. So here one is quadratic, the other is linear. So you have to use a substitution method. And that's why here we have written y in terms of x. You can also write x in terms of y. You can also write x in terms of y. That is 4x plus 10y minus 23 is equal to 0. So I have written 10y is equal to 23 minus 4x. So y is equal to 23 minus 4x by 10. I have written y in terms of x. You can also write x in terms of y. To use a substitution method, you can also write x in terms of y. How do you do that? So 4x plus 10y minus 23 is equal to 0. So 4x is equal to 23 minus 10y. 4x is equal to 23 minus 10y. X is equal to 23 minus 10y by 4. You can also write x in terms of y. I have written y in terms of x. And I've substituted that in the second equation. I've called this 1. Y in terms of x, I've called it 1. And I substitute this result in the second equation here. So here in this equation, wherever there is y, we replace that with 23 minus 4x by 10. Okay, so substituting 1 in 2. Substituting 1 in 2, we get x square is x square. This y square is 23 minus 4x by 10 the whole square. Wherever there is wherever there is y, use 23 minus 4x by 10. Now, what has happened? The equation actually had two unknowns x and y. Now, after substituting, there is only one unknown x. So that's how the substitution method works. So in an equation, when you have two unknowns, when you use a substitution method, you're replacing one variable with with another variable, right? So now the entire equation is only one variable. Here it is x. Now we need to work this equation and find the values of x. So let's see how to work it. See x squared as it is. X squared as it is. Now this is like a by b the whole squared. So I have written it as a squared by b squared. All right. Okay, so that's what you see here. 23 minus 4x the whole square by 10 square is 100. Then this minus 4x as it is. Here, children, see, this is where we'll have to be careful. This minus, here minus as it is. Multiply only the 3 with the terms inside the bracket. Only when you take the LCM, this minus, you'll have to multiply the minus sign inside. Now you'll have to multiply only 3 inside the bracket. Multiply only 3 inside the bracket. Okay. So minus 3 into 23 is 69 and 3 into minus 4x is minus 12x. Don't get confused why it is not plus 12x. That this minus is a connecting sign. And that connecting sign will be used only when you take the LCM. When you take the common denominator, then you should multiply this connecting sign with the terms inside the bracket, not now. So now it is only 3 into 23 is 69 and 3 into minus 4x, which is minus 12x by 10. And this minus is the connecting sign. Minus 1 is equal to 0. Now the common denominator, 100 is LCM, right? 100 is a common denominator. So then that part, so it will be 100x squared. And I have expanded this. This will be 100x squared. And here I've expanded a minus b the whole square is a squared plus b squared minus 2ab. And this will be into 100. So minus 400x. And this will be into 10. It will be into 10. Now you're taking the LCM. So into 10, when you multiply this by 10, you will get minus 690. See here, minus 690 minus into minus plus 120x. Minus 690 minus into minus plus 12x into 10 is 120x. Minus there is 1 here. So into 100 because 100 is LCM. It's by 1, no? So into 100. So minus 100 is equal to 0. Now cross multiply. When you cross multiply, what happens? 100 into 0 is 0. It's gone. And there are like terms here, x squared, and then this is a constant. This is also a constant, x. So please simplify, and this is what you get. 116x squared minus 464x minus 261 is equal to 0. Now, 29, all these numbers are divisible by 29. So divide by 29 throughout. All these numbers are divisible by 29. All right, so divide by 29 throughout. So that makes the equation easier, simpler. 4x squared minus 16x minus 9 is equal to 0. Then split the middle. It's a quadratic equation. So split the middle term. And these are the two values for x. X is equal to 9 by 2 or x is equal to minus 1 by 2. Now we know y is equal to 23 minus 4x by 10. So for each value of x, find the corresponding value of y. So when x is 9 by 2, what's the value of y? It's 1 by 2. So x comma y, 9 by 2 comma 1 by 2. 9 by 2 comma 1 by 2. Then when x is minus 1 by 2, y will be 23 minus 4 into minus 1 by 2 by 10. Because that's what it is. Y is equal to 23 minus 4x by 10. So that works. So you can cancel, no, here 2 1s are 2 2s are. 2 1s are 2 2s are. Okay, so you get 5 by 2. So when x is minus 1 by 2, y is 5 by 2. So these are the two sets of coordinates you get for B. We've assumed B as x comma y, right? So the coordinates of B can be 9 by 2 comma 1 by 2 or minus 1 by 2 comma 5 by 2. So we say if these are the coordinates of B, then these are the coordinates of D. Or if these are the coordinates of B, then these are the coordinates of D. That's what here. Therefore, if B takes these coordinates, then D will take the others. Or if B takes this one, then D takes the other one. Very simple, meaning the idea is very simple in working, but you'll have to be careful with the signs and, all those algebraic tasks, you should be very careful, expanding, simplifying the like terms. Otherwise, the idea is very simple. So here in this question, the quadrilateral is a square, and we know the coordinates of the diagonally opposite vertices, A and C. ABCD is a square. We are given the coordinates of two diagonally opposite vertices, A and C. we need to find the coordinates of the other two vertices B and D. So we work with two conditions. We have assumed B as x comma y. So we have to work with the coordinates A, B, and C. So condition 1, AB is equal to BC because it's a square, all sides are equal. Condition 2, Pythagoras theorem, AC square is equal to AB square plus BC square. So from the first condition, you get from the first condition AB is equal to BC, you get this linear equation in X and Y. From the second one, Pythagoras theorem, you get something like this. It's a quadratic equation in X and Y. So we further, continue to solve by using the substitution method. So we go back to this equation and we write y in terms of x. We substitute that in the second equation. So now this equation has only variable x. So as we work, we get a quadratic equation, split the middle term, we get two values for x. How to find y with x values? With x values, how do you find y? Here. With x values, how do you find y? Y is equal to 23 minus 4x by 10. So for each x value, find the corresponding y value using this. So you have two sets of coordinates. Now if B is this, D is this. Or if B is this, then D is this. This is about this question. Next one. Yeah. So this is similar one, children. A similar question. Two opposite vertices of a square are P minus 1, 2 and R 3, 2. Find the coordinates of Q and S. Similar question. Okay. Here also we have the coordinates of two diagonally opposite vertices. We have to find the coordinates of the remaining two vertices. So same. So here we have called Q. Let Q be, see here, let the coordinates of Q be x comma y. Let the coordinates of Q be x comma y. So P, Q, R. Okay, so first PQ is equal to QR. PQ is equal to QR or PQ square is equal to QR square. So when you work this, earlier we got a linear equation in X and Y. Here, we're directly getting the value of X. X is 1. So this is simpler. So anything you can get, see, it's not that you will always get a linear equation X and Y like you got earlier. So see here, when you work with the condition PQ is equal to QR, you're able to get the value of X. X is equal to 1. Next condition, Pythagoras theorem. PR square is equal to PQ square plus QR square. So you know how to work PR square, PQ square, and QR square. So expand here. These are numerical. You can see these are numerical. So you get 16. Okay, so this one is numerical. So you get 16. Now here you'll have to expand using the algebraic identities a plus b the whole square, a minus b the whole square. So I've simplified, see it, I've simplified the like terms x square, y square, y square. Okay, so after simplifying, I get 2x square minus 4x plus 2y square minus 8y plus 18. Now at this point, we know x is 1. See, now you can even put x1 here, children. You can also put x1 here also. That'll be a little more easier actually. You can take x as 1 here itself. That is, see, when you're working, what you can do, no? Now q is x comma y, right? So that means q is 1 comma y. Q is 1 comma y. Because x is 1. So q is 1 comma y. So when you find a pq square and qr square, you can find with 1 comma y. I have found here with x comma y itself. So a little elaborate this has become. You don't have to work like me. I would have just done it mindlessly without meaning, x is 1, I would have just ignored. So actually, mindful working, this is correct. You should take, q as 1 comma y in the next step. So that will make your work easier because this will become 1, no? So 1 plus 1, 2, 2 square is 4. Directly we'll get. And here also, 1 minus 3 minus 2. Minus 2 squared is 4. So that will make your work a little easier. So don't do like what I have done. This is not wrong, but don't do like what I have done here. Okay. So please, after getting x is equal to 1, no, so you know q is 1 comma y. So when you're finding pq square and qr square, please use these coordinates of q. Okay, I hope all of us understood. So now, so what I have done is I've expanded, and then after simplifying, x is 1, no, x is 1, so I've substituted. So then y remains in the equation. We get a quadratic equation, you see here. 16 is equal to 2y square minus 8y plus 16. So plus 16 on either side gets cancelled. So we have 2y square minus 8y. 2y square minus 8y is quadratic, but we don't have all the three terms. Only when you have all the three terms, you can solve by splitting the middle term. We don't have all the three terms. So here you'll have to take out the common factor. 2y is common. 2y is common. So 2y into y, 2y square, 2y into minus 4 is minus 8y. So take out 2y common. Then 2y is equal to 0 or y minus 4 is equal to 0. 2y is equal to 0 or y minus 4 is equal to 0. So 2y is equal to 0, y is 0. Y minus 4 is equal to 0, y is equal to 4. So for a single value for x, we have two different values for y. So for one value of x, we have two different values for y. So the coordinates of q can be 1, 0 or 1, 4. The coordinates of q can be 1, 0 or 1, 4. So we say if q is 1, 0, then s is 1, 4. Or if q is 1, 4, then s is 1, 0. So like this, we find the coordinates of q and s. Okay, next one. I'll just share these images on WhatsApp. I'll teach till about 8:30. I have a set of I want to finish this today. So today we'll wind up with coordinate geometry, and I'll ask you which chapter. I'm planning to start triangles next. Anyways, we'll discuss it at the end of the session. So I want to finish off coordinate geometry today. So I'll just explain, like whatever I have to, and then I'll share the images with you on WhatsApp. So as much, so by till 9:30, whatever is possible, you can complete during the session, and the remaining you can finish it, like after the class, before the next class. Yeah. So I'll just continue explaining the other questions. Look at this one. An equilateral triangle has two vertices at 3, 4 and minus 2, 3. Find the coordinates of the third vertex. An equilateral triangle has two vertices at 3, 4 and minus 2, 3. Find the coordinates of the third vertex. Okay. So now we are looking for conditions, like you need to construct some equation and you should work with the equation. So here in an equilateral triangle, see, these are the conditions. So for a square, we worked with these two conditions. The sides are equal, PQ is equal to QR. And then Pythagoras theorem. These are the two conditions we used to construct equations. So here in an equilateral triangle, we know that all the sides are equal. So the condition is all the sides are equal. AB is equal to BC is equal to AC, or AB square is equal to BC square is equal to AC square. So that's the only condition. But from this, you can do three cases, only one condition, but you can do three cases. You can work AB square is equal to BC square. So, okay, that's one thing, case one. BC square is equal to AC square. You just need one equation, right? So you have three equations here. AB square is equal to BC square. BC square is equal to AC square. AB square is equal to AC square. But you know what? Sometimes situations here can be a little complicated. So you need to carefully select which cases, to work. Like, should I work AB square and BC square to be comfortable, or BC square is equal to AC square, or AB square is equal to AC square? So we should, that decision making, we'll see. We'll just understand how. So we have to make that, we'll have to give a little thought and then, proceed with whichever cases, two cases. So we'll see how to decide that. So this is AB square. We'll have to find AB square, BC square, AC square, right? Using the distance formula. Equilateral triangle, only one condition, all the sides are equal. AB is equal to BC is equal to AC, which means AB square is equal to BC square is equal to AC square. Now I found AB square separately, BC square separately, AC square separately. So we get AB 26 units, AB squared, sorry. BC square is this expression and AC square is this expression. Okay. Now, when you work, BC square is equal, I'll tell you this later, this one. When you work BC square is equal to AC square, BC square is equal to AC square. You know what will happen when you work BC square is equal to AC square? This X square and X square will get cancelled. Y square and Y square will get cancelled. So see here, you're able to get a linear equation in X and Y. See, a linear equation in X and Y is comfortable than a quadratic equation in X square, Y square, X and Y. Like this one. A quadratic equation involving X square, Y square, X and Y. This is a little more, complicated when compared to a linear equation in X and Y. So when I said you'll have to select, this is what I meant. When you equate BC square and AC square, when you equate BC square and AC square, BC square is equal to AC square, X square on either side will get cancelled, Y square on either side will get cancelled. So then you will be left with only X terms, Y terms and constants. So which means you can get a linear equation in X and Y, or maybe you'll get, even if the Y terms get cancelled out, you will get the value of X or the value of Y. If the X terms get cancelled out, you will get the value of Y, or if the Y terms get cancelled out, you will get the value of X. So I've worked BC square is equal to AC square. BC square is equal to AC square. And then any one you can work. You can work AB square with, because see, look at the expressions here. These two are almost similar, no? These two are almost similar. We have to work BC square equal to AC square, children. That's what I'm trying to say. We have to work BC square equal to AC square. Because in both we have X square, in both we have Y square. So we have to work this one. Okay, so this is compulsory. Now then one more, anything you can decide. So I have done AB square is equal to BC square. You can also do AB square is equal to AC square. Okay. Equating the two equations that have X square and Y square is very important. All right. So that's what it is. So when you equate AB square and BC square, you can see here, this is what we have. BC square and AC square, when you equate, X square on either side gets cancelled, Y square gets cancelled, and you get this linear equation X and Y. You can divide by 2 throughout. You can divide by 2 throughout, and you get a simpler equation. And since the first equation is quadratic, we have to solve by the substitution method. So I have written Y in terms of X. Y is equal to 6 minus 5X. I've written Y in terms of X. All right. So now I substitute. I put this one in the first equation, this one. Second one is linear. First one is quadratic. So from this linear equation, we write Y in terms of X and we substitute that in the first one. Where in the first equation, wherever there is Y, we use 6 minus 5X. So wherever there is Y, here there is Y. So 6 minus 5X the whole square. Here there is Y, minus 6Y. So minus 6 into Y. So now this equation has only one variable X. So work it carefully. Plus minus, you'll have to be very, very careful. So this is the equation you get. You can see you can divide by 13 throughout. You get this equation. Now You're not able to, split the middle term, because if the roots are irrational, see, splitting the middle term is easy only when you can find rational roots. Rational, not even rational, only integral, meaning integer roots. It's difficult to find. It's difficult to guess irrational roots or fractions roots, like to split the middle term if the numbers are -1/4 and 11/3. How can you guess all that? So splitting the middle term, you can use that method for, when you have a quadratic equation and you have to, solve to find the values of the variable. You can use splitting the middle term only when the roots are integral, made up of integers. Only integer factors you can guess. So if you cannot guess, then you have to use a quadratic formula. So I've used a quadratic formula. See here, the a is 2, y is 2, because 2x squared minus 2x minus 1. So a is 2, b is -2, and c is -1. Okay. The quadratic formula, x is equal to minus b plus or minus root of b square minus 4ac by 2a. See why? Because we were unable to split the middle term. We were unable to guess the two numbers to split the middle term. So we don't spend time. Quadratic formula. Okay. So this is the quadratic formula, and see here you get 2 plus, you get root 12. Root 12 should be written as 2 root 3. Important. 2 root 3. Then 2 is common. 2 is common. Right? So then you get 2 into, in brackets, 1 plus or minus root 3 by 4. Now 2 ones are 2 twos are. So x is equal to 1 plus root 3 by 2, or x is equal to 1 minus root 3 by 2. So first we use a quadratic formula because we were unable to split the middle term. We were unable to find the two numbers to split the middle term. So quadratic formula. When we use a quadratic formula, we have root 12, which should be written as 2 root 3. Mixed is up. Then there's 2 common in the numerator, so you'll have to take out 2 common. You can cancel 2 and 4. Now this is 1 plus or minus. So x is equal to 1 plus root 3 by 2, or x is equal to 1 minus root 3 by 2. Now we'll have to find the corresponding y values. For these x values, you should find the corresponding y values. So substituting x is equal to 1 plus root 3 by 2 in equation 2. Y is equal to 6 minus 5x. Y is equal to 6 minus 5x. Okay. So y is equal to 6 minus 5 into x, 1 plus root 3 by 2. So LCM, I've taken the LCM also. Y is equal to 2 is the common denominator. So 6 2s are 12 minus 5 into 1, 5 minus 5, minus into plus minus 5 root 3. Sorry, minus into plus minus. Oh, I think I said the same. I'll just repeat. Meaning I didn't hear what I said. I said I took up the common denominator here too. So 2 into 6, 12, because it's by 1, no? So 12. And then minus 5 into 1, minus 5, minus into plus minus, 5 into root 3, 5 root 3 by 2. So 12 minus 5 is 7, minus 5 root 3 by 2. So when x is 1 plus root 3 by 2, y is 7 minus 5 root 3 by 2. Similarly, find when x is 1 minus root 3 by 2, the y value. So same thing. 6 minus 5x, in place of x, use 1 minus root 3 by 2, LCM, and yeah. So when x is 1 minus root 3 by 2, y is 7 plus 5 root 3 by 2. So these are the coordinates of C. This is a triangle. This is an equilateral triangle. We were given the coordinates of A and B, and we had to find the coordinates of C. So C can take these coordinates or these coordinates. Like supposing you plot 2 points of an equilateral triangle. Say you plot 2 points like this. Okay. The third point can be here or here, no? Equilateral triangle, you know the coordinates of A and B. You have to find the coordinates of C. Okay. So equilateral triangle. So the coordinates of C can be here, a point here. So A, B, C, like this. Or C can be here. That's why we get 2 sets of coordinates for C. Both are acceptable. C can take this address or this address. Yeah, class, use the emoji, raise your hand. Akshita, Aragamai, Aniruddhan, Hasif, Prenu, Krishnapriyan, Anugraha, Srivatsan, Kamalika, Niveda, Pratish, what about Tanishka? Okay. Thank you, children. Any questions? Of course, see, only when you work, you will actually make out your difficulty. But I'm like asking concept wise, anything is not clear. Okay. So we've seen 2 different questions. The first question in today's class was about a square. The coordinates of 2 diagonally opposite vertices were given, and we had to find the coordinates of the remaining 2 vertices. To answer that question, we have to work with 2 conditions. One is all the sides of a square are equal, and then Pythagoras theorem. And when you get from one condition, you get a linear equation in x and y. From the other condition, you get a quadratic equation in x and y. Then we have to use a substitution method. You have to write x in terms of y. From that linear equation, you should write x in terms of y or y in terms of x. Substitute that in the second one, the quadratic equation. And yeah, so, and then you proceed to get the final answer. The second type is an equilateral triangle, 2 vertices given. You'll have to find the coordinates of the third vertex. So you'll get 2 answers for this. We just plotted, no? We just plotted and understood that if this one and this one are the coordinates of A and B of equilateral triangle ABC, then C can be here or C can be here. So you get 2 answers for C. And the condition is only one condition. Equilateral triangle, we only know all sides are equal. In an equilateral triangle, all the sides are equal. So AB is equal to BC is equal to AC, or AB square is equal to BC square is equal to AC square. And you must equate the 2 expressions having x square and y square. You should equate the 2 expressions having x square and y square. This is compulsory. Then you can equate any one. You can, not any one. Then you can equate AB square with BC square or AB square with AC square. But BC square is equal to AC square is compulsory because both the expressions have x square and y square. That was the second one we saw. So this is a similar one, children. So you can try this yourself. If two vertices of an equilateral triangle, BO 0, 0 and A 3, root 3, find the coordinates of B. Similar. So here you can see that this one is x square plus y square, and this one is also x square, y square, 6x and all that. So we've equated these two. Here, OB square is equal to AB square. OB square is equal to AB square. Then, see here. Now, and then it's easy to equate these two, no? Instead of equating this and this, instead of doing OA square is equal to AB square, look at the expression. That's what I said earlier. You must look at the expressions and decide which to equate. See, you have to equate these two because only then x squared, y squared, x squared, y squared will get cancelled and you'll get a simple equation. Then the other one to equate is equate this and this because it's simple. No, you have fewer terms. X squared plus y squared is equal to 12. Then equating these two, you will get x squared minus 6x plus 9 plus y squared minus 2 root 3y plus 3 is equal to 12. When compared to that, this is easier. You have lesser terms. So equate these two. Just a second. Yeah, thank you, children. So where do we stop? Yeah. So yeah, I was telling you about the equation. So now that we have these two equations, x squared plus y squared is equal to 12. And this one, 6x plus 2 root 3y minus 12 is equal to 0. Now this one is linear. This one is linear. So we have to, this one is quadratic. So we have to use a substitution method. This is quadratic, this is linear. So from this linear equation, you'll have to write x in terms of y or y in terms of x. So I have written x in terms of y. X is equal to 6 minus root 3y by 3. Always use the linear equation to write x in terms of y or y in terms of x. And substitute that in the quadratic equation. This equation is quadratic. This is linear. Use the linear equation to write one variable in terms of the other variable. So I have written x in terms of y. Substitute this in the quadratic equation. So where there is x, use 6 minus root 3y by 3. So that way you'll be able to find the value of the values of y. You see here, substitute that. This is from the second equation. So substitute this in the first one. X squared plus y squared is equal to 12. So x squared plus y squared is equal to 12. So this is nothing but 6 minus root 3y the whole square. 6 minus root 3y the whole square. So expanded. A minus b the whole square is a squared minus 2ab plus b squared. Divided by 3 square is 9. Plus y square is equal to 12. It's not there. I've erased it with white now. I've expanded the numerator. A squared minus 2ab plus b squared. 3 squared is 9. And this plus y squared is equal to 12. Then I've taken the LCM. So you can see 36 minus 12 root 3y plus 3y squared. Then 9y squared. No, when you take the LCM, 9y squared. By 9 is equal to 12. I've cross multiplied that. So that 9 into 12 is 108. I've written 108. After taking the LCM, this will become 9y squared. Like this it will be. I've cross multiplied 12 into 9, 108. Okay. So 3y squared and 9y squared is 12y squared minus 12 root 3y minus when you simplify these two. 108 and 36 minus 72 is equal to 0. Again, 12 is common. 12 is common. Bring all the terms to one side because it's quadratic, right? So bring all the terms to one side. Bring all the terms to one side. And you can see that 12 is common. So divide by 12 throughout. So you get 12y squared divided by 12, y squared. 12 root 3y divided by 12, root 3y. And 72 divided by 12 is 6. Now I've split the middle term. You can see here how to find the factors. The product is 6. You can use a quadratic formula otherwise. You can also use a quadratic formula. This is the product 6, which is 2 into 3. But the sum is asserted in root 3. So I have written 3 as root 3 into root 3. 3 as root 3 into root 3. So the two numbers are 2 root 3 and root 3. 2 root 3 and root 3. Fix the signs carefully. The product is 6 and the sum is root 3 minus root 3. The product is okay, minus 6 and the sum is minus root 3. So 6 is 2 into 3. But since the sum is root 3, we'll have to further break down 3 as root 3 and root 3. So the two numbers are 2 root 3 and root 3. Fix the signs accordingly. So split the middle term. And yeah, these are the values for y. And now for each value of y, find the corresponding value of x using this one. So when y is 2 root 3, x is 0. And when y is minus root 3, x is equal to 3. So x comma y, the coordinates are x comma y. So 0 comma 2 root 3, 3 comma minus root 3. Okay, so the third vertex B can be 0 comma 2 root 3 or 3 comma minus root 3. See in this one, children, similar question, equilateral triangle, 2 vertices are given, you should find the third one. So the condition is AB is equal to BC is equal to AC, AB square, BC square, AC square, find them. And then equate the two equations that have x square and y square. So this one and this one compulsory. Equating 1 and 3 is compulsory. When you do that, see directly you're getting x is 0. X is 0. So you found the value of x. Okay, now, so one condition we worked with. One, I've numbered it 1, 2, and 3. We already equated 1 and 3. 1 is equal to 3. Now I've equated 1 and 2. Anything, you can also equate 3 and 2. Anything. So I've equated 1 and 2. And we know that x is 0. So use x is 0. So we're able to find the value of y. So you can expect a simple question like this, which is less time consuming in the exam. So when you equate 1 and 3, you get the value of x. Then 1 and 2 I have done here. Use x as 0. So you get y square is equal to 48. Y is equal to plus or minus square root of 48. 48 is 16 into 3, which is 4 root 3. X is 0, y is plus 4 root 3, x is 0, y is minus 4 root 3. These are the two different coordinates of C. This is another type. Find the coordinates of the circumcenter of a triangle. Now, what is the circumcenter? All of us know. The circumcenter is the center of the circumcircle. The circumcenter is the center of the circumcircle. Circumcircle. Okay, let me start from here. Circle center. Circumcircle. Circumcenter. In circle. In center. So circumcenter is the center of the circumcircle. And what is a circumcircle? Circumcircle is a circle passing through the 3 vertices of the triangle. The circle passing through the 3 vertices of the triangle is a circumcircle. In circle is the circle drawn inside the triangle, touching the 3 vertices of the triangle. In circle, in center. Circumcircle, circumcenter. Okay, so now in center we don't have. Leave that. A circumcenter. Now, when you join the circumcenter to the vertices, that's nothing but the circumradius, no? I'll come again. See here. What is a circumcircle? It's a circle which is drawn through the drawn passing through the vertices of a triangle. Okay, it's a circle drawn passing through the vertices of a triangle. There's a circumcircle. Every circle has a center, no? So a circumcircle has a circumcenter. And when you join the circumcenter to the vertices of the triangle, now these are equal because that's nothing but the radius. That's nothing but the radius of the circle or the circumcircle. So the condition here is OA is equal to OB is equal to OC, where O is the circumcenter. The question is, find the coordinates of the circumcenter of the triangle with vertices ABC given. Then also find the circumradius. So what is the condition to work here? What is the condition? We know that OA is equal to OB is equal to OC. Because what is OA? Radius. OB? Radius. OC? Radius. O? Circumcenter. So that's the condition. Now you know how to work with this condition, children. Similar to what we did with equilateral triangle. So I'm not explaining that. And then after finding the coordinates of the circumcenter, how do we find the circumradius? So circumradius, once you find the coordinates of the circumcenter, you know this address. How do you find the circumradius? Using the distance formula, OA, or find OB, or find OC, using the distance formula. The question is to find the coordinates of the circumcenter and also to find the circumradius. So let the coordinates of the circumcenter be OX, Y. Condition is OA is equal to OB is equal to OC. Because that's nothing but the radius of the circle. So OA square is equal to OB square is equal to OC square. Okay. I think I've finished all the types. 1 second. I'm submitting. Okay. So here in this question, two vertices of an isosceles triangle are 2, 0 and 2, 5. Isosceles triangle, two vertices are given, 2, 5 and 2, 0. Find the third vertex. This is isosceles triangle. Earlier we saw equilateral triangle. Find the third vertex if the length of the equal sides is 3 units. Okay. All right. Now here, in an see, you'll have to be careful here, children. In an equilateral triangle, you know, all the three sides are equal. Isosceles triangle, two sides are equal, but which two sides are equal, we don't know. We know the address of, here we have called the triangle what? PAB. Okay, I've called the triangle PAB. We know the address of A and B. A 2, 0 and B 2, 5. We don't know the address of P. But it's given that the equal sides have length 3 units. Okay, so with the given information, we can find this distance AB. Find AB. What is AB? 5 units. Oh, that means these two sides are equal. Because equal sides is 3 units, no? See, it's given that the equal sides are 3 units. Equal sides 3 units. Now, when you find the distance between these 2 points, you get 5 units. So AB is 5 units. The equal sides are 3 units. That means these 2 sides are equal and they're equal to 3 units each. Okay. So since we know the coordinates of A and B, by using the distance formula, you can find the length of the line segment or length of the side AB. That is 5 units. But equal sides are 3 units. So that means these two have to be the equal sides because this is 5. But the equal sides are 3. So these two sides have to be equal. So isosceles triangle condition. What's the condition? Isosceles triangle. 2 sides are equal. Right? But here the lengths of the equal sides are given to you, 3 units. So you know that this one is how much? 5 units. You know this is 3. And you also know this is 3. So PA is equal to 3 units or PA square is equal to 9. Similarly, PB is equal to 3 units or PB square is equal to 9. Because you know PA is 3 units. So PA is equal to 3 units. So PA square is equal to 3 square 9. How do you find PA square? Distance formula. X2 minus x1 the whole square plus y2 minus y1 the whole square. So when you work that, you get a quadratic equation x and y. Then PB square, I work PB square. When you work that, you get a quadratic equation in x square, y square, x and y. Okay. Now you can do it in different ways. Now what I have done here is, we know that x square minus 4xy plus y square is 5. X square minus 4xy plus y square is equal to 5. We know that this expression value is 5. We have the same expression here. So it's 5. So 5 minus 10y is equal to minus 20. So when you work this, you get the value of y. Then by substituting the value of y in one of the two equations, you're able to get the values of x. So here it's difficult to split the middle term. So we use a quadratic formula and we find the two values of x. Important question. So what here? Two vertices of an isosceles triangle are given. Should find the third vertex. So first, using the distance formula, find the length of the line segment AB because you know A and B. Find AB. AB is 5. It's given that equal sides are 3. So that this is 5. So these two should be the equal sides, 3. PA square. PA is equal to 3. PA square is equal to 9. PB is equal to 3. PB square is equal to 9. And we know how to apply the distance formula and find PA square and PB square. So PA square gives you this equation. PB square gives you this equation. But in this, you know that x square minus 4y plus y square is equal to 5. This one is 5. When you substitute, you are able to find the value of y. And then again, y in one of the two equations, you'll get the value of x. You'll get the values for x. Got it. Yeah, go through the first question. I'll just come back to it and please go through this. Yeah, I'm back, children. Thank you. Okay. In this question, if the if the centroid of triangle ABC with A comma B comma C, and C comma A is the origin. So the centroid is at the origin. The centroid is at the origin. Find the value of A plus B plus C. So you can draw this figure to show this information, A, B, C. And you can take any median. I have taken median AD, that is from A on BC. You can take any median, like you can draw the median from A or from B or from C, any median. You can take any median from vertex A or vertex B or vertex C. Okay, so I've taken the median AD. And we know that the centroid lies on the median, right? So the centroid is at the origin. So G, 0, comma 0. G is the letter. Centroid is normally named using the letter G, capital letter G. Okay, so G is 0, comma 0 because it's at the origin. Okay, so now we need to find the value of A plus B plus C. Now we know that D is the midpoint of BC. D is the midpoint of BC. So you can find the coordinates of D using the midpoint formula. B plus C by 2, C plus A by 2. And we know that the centroid divides the median, the ratio 2 is to 1. So you can see I've shown that AD here horizontally. This AD, no, I've represented here horizontally. So this one, A comma B. This D is what? B plus C by 2, A plus C by 2. And centroid. And I've told you, from the vertex to the centroid, 2 paths. From the vertex to the centroid, 2 paths. From the centroid to the midpoint, 1 part. You can see 1 here. So G is the point of division. G divides the median AD in the ratio 2 is to 1. From the vertex to the centroid, 2 parts. From the centroid to the midpoint, 1 part. Now use the formula, the section formula. You know that the coordinates of G. You know both the coordinates of G. So you can either use the x coordinate of G or the y coordinate of G. Use anything. Now I've taken the x coordinate of G is 0. So mx2 plus nx1 by n plus n is 0. So mx2, 2 into b plus c by 2 plus 1 into a by 2 plus 1, 3 is equal to 0. So when you work this, you see that a plus b plus c is equal to 0. You will get the same result using any median, AD or from B or from C. You can also use the y coordinate of G. Y coordinate of G is equal to 0. My2 plus ny1 by m plus n is equal to 0. M, that is 2, into y2 is a plus c by 2 plus n1 into y1 b by m plus n, 2 plus 1 is equal to 0. So 2 cancels out. A plus c plus b by 3 is equal to 0. So a plus b plus c is equal to 0. Okay, so that's about this question. Next one. Find the vertices. Sorry. This is Find the values of x and y if the distance of the point P from A and B is 4 units. Find the values of x and y if the distances of the point P, x comma y from A and B are 4 units. So that means PA, distance of P from A is 4 units. The distance of P from B is 4 units. P from A, 4 units. P from B, 4 units. So PA is 4, PB is 4. So that means PA square is 16, PB square is 16. So you can see. So what you can do is, you have this equation equal to 7. This is also equal to 7. So you can equate both, or you can subtract the two equations. Both are the same. Equating the two equations, subtracting the two equations, both are the same. See, when you work PA square is equal to 16, you get this expression equal to 7. PB square equal to 16, this expression equal to 7. So both the equations are equal to 7, right? So you can equate x square plus 6x plus y square is equal to x square minus 6x plus y square. RHS is equal to RHS. So you can equate LHS is equal to LHS. X square plus 6x plus y square is equal to x square minus 6x plus y square. Or you can subtract like this. You can write the equations one below the other and subtract the two equations. You can also write the equations one below the other like this and subtract the two equations. So change the signs throughout in the second equation. In the second equation, change the signs throughout. So you see x square minus x square, y square minus y square cancels. 6x plus 6x, 12x is 0. So x is equal to 0. So when you substitute x is equal to 0, in any one equation, 1 or 2, you get y is plus or minus root 7. So these are the values of x and y. So it's given the distance of P from A is equal to 4. PA is equal to 4. Distance of P from B is equal to 4. PB is equal to 4. So there itself you have two equations. PA is equal to 4. PB is equal to 4. So work and get the equations in x and y. So this one and this one. Observe the two equations. Both of them are equal to 7. So because RHS is equal to RHS, you can equate LHS is equal to LHS. Or you can write the equations one below the other like this and subtract. So you get x0. When you substitute x0 in one of the two equations, you get y is equal to plus or minus root 7. When I say equate, you can also do this. X squared plus 6x plus y squared is equal to x squared minus 6x plus y squared. That is the left-hand side is equal to the left-hand side. Because RHS is 7 here and 7 here. So this LHS is equal to this LHS. So x square on either side gets cancelled. Y square on either side gets cancelled. 6x minus 6x on the other side plus 6x is equal to 0. So 12x equals 0. X is equal to 0 by 12, which is 0. Okay, yeah, we've discussed all the important questions from coordinate geometry, which I had in this material. Yeah, children, please work this one. Yeah, please work this one, all of you. Take down question number 7 and please try that. Yeah, found the coordinates, children, of PQRS. All right, children. So as we see here, you can find the coordinates of P. Okay, you can, the line segment AB is divided into 5 equal parts. AP, PQ, QR, RS and SB. All right. We'll have to find the coordinates of PQR and S. This I've forgotten to type it. Not only PQR and S it is. So you can find P first like this. You can find P using the ratio 1:4. Right? P divides AB in the ratio 1:4. So you can find the coordinates of P first, and then you can always use the midpoint formula. Yeah, you can go through. Then you can use the midpoint formula. It's not that you should always use the full line segment AB. You can use a part of it also. So then I use only PB, PQ, R, S, and B. Only this segment I used, where R is the midpoint. R is the midpoint of, because there are 5 points, no? P, Q, R, S, B, 5 points. So the third point will be the midpoint. So you can find the coordinates of R using the midpoint formula. Now you know P and R. So you can find Q using the midpoint formula because P, Q, R. So Q is the midpoint of PR. In the same way, you can find the coordinates of S using the midpoint formula because S is the midpoint of RB. S is the midpoint of RB. Okay. Next one. All right, next one. Yeah, please try this one, children. So because P is the midpoint, P is the midpoint of AQ. So you can use the midpoint formula, x1 plus x2 by 2, 3 plus 5 by 3 by 2 is equal to P, is equal to P. So 9 plus 5, 14, 14 by 3, 14 by 3 divided by 2, so it will be into 1 by 2 is equal to P. So 2 ones are 2 sevens are. So this implies P is equal to 7 by 3. Similarly for Q, Q is the midpoint. Q is the midpoint of PB. So again using the midpoint formula, you have to find this Q, which is the y coordinate. So we'll use y1 plus y2 by 2. y1 plus y2 by 2 is equal to Q. Here the small letter p is the x coordinate. Small letter q is the y coordinate. So we'll have to use the y coordinate formula. y1 plus y2 minus 2 plus 2 by 2 is equal to q. So q is equal to 0. All right, next one. Yeah, I shared these questions as homework. Yeah, try this one now, children. Try this now. Oh, sorry, the line segment PQ. I had a mistake. Sorry. The line segment is PQ. P3, 3, Q 6, 6. It's trisected with the points A and B, and A is nearer to P. Okay, A is nearer to P. If A also lies on Yeah, I think you can finish this. Because it's trisected, the ratio is 1:2. PA is to AQ. PA, this is one part, one part, one part. So PA is to AQ is the required ratio. That is 1:2. PA is to AQ is 1:2. So by the distance formula, the coordinates of A, sorry, by the section formula, the coordinates of A, mx2 plus nx1 by m plus n, my2 ny1 by m plus n. 6 plus 6, 12 by 3, 4 minus 6 plus 6. 0. I hope I'm right. Now, this one lies on 2x plus y plus k is equal to 0. So it will satisfy the equation. So a 4, 0 lies on 2x plus y plus k is equal to 0. So it will satisfy the equation. So 2 into 4 plus 0 plus k is equal to 0. So k is equal to minus 8. The value of k is minus 8. All right, children. So that's it for today's session. I'll share the images the contents of all those images which we discussed in today's class. I'll share it on WhatsApp. Please complete the notes. All right, children. That's it for today's session. Thank you so much. Good night. You may all leave the call.
Thank you, ma'am.
Thank you. Good night.
Good, ma'am.
Thank you, ma'am.
Thank you, children. Good night.